Design and ergonomics. Chair design considers intended usage, ergonomics, how comfortable it is for the occupant, as well as non-ergonomic functional requirements such as size, stacking ability, folding ability, weight, durability, stain resistance, and artistic design. Intended usage determines the desired seating position. Task chairs, or any chair intended for people to work at a desk or table, including dining chairs, can only recline very slightly, otherwise the occupant is too far away from the desk or table. Dental chairs are necessarily reclined. Easy chairs for watching television or movies are somewhere in between depending on the height of the screen. Ergonomic design distributes the weight of the occupant to various parts of the body. A seat that is higher results in dangling feet and increased pressure on the underside of the knees, popliteal fold. It may also result in no weight on the feet, which means more weight elsewhere. A lower seat may shift too much weight to the seat bones, ischial tuberosities. A reclining seat and back will shift weight to the occupant's back. This may be more comfortable for some in reducing weight on the seat area, but may be problematic for others who have bad backs. In general, if the occupant is supposed to sit for a long time, weight needs to be taken off the seat area, and thus easy chairs intended for long periods of sitting are generally at least slightly reclined. However, reclining may not be suitable for chairs intended for work or eating at table. The back of the chair will support some of the weight of the occupant, reducing the weight on other parts of the body. In general, backrests come in 3 heights. Lower back backrests support only the lumbar region. Shoulder height backrests support the entire back and shoulders. Headrests support the head as well and are important in vehicles for preventing whiplash neck injuries and rear-end collisions where the head is jerked back suddenly. Reclining chairs typically have at least shoulder height backrests to shift weight to the shoulders instead of just the lower back. Some chairs have footrests. Around 15% of women and 2% of men need footrests, even at the 16-inch chair height. A stool or other simple chair may have a simple straight or curved bar near the bottom for the sitter to place his or her feet on. Some chairs have 2 curved bands of wood, also known as rockers, attached to the bottom of the legs. They are called rocking chairs. A kneeling chair adds an additional body part, the knees, to support the weight of the body. A sit-stand chair distributes most of the weight of the occupant to the feet. Many chairs are padded or have cushions. Padding can be on the seat of the chair only, on the seat and back, or also on any armrests or footrest the chair may have. Padding will not shift the weight to different parts of the body, unless the chair is so soft that the shape is altered. However, padding does distribute the weight by increasing the area of contact between the chair and the body. A hardwood chair feels hard because the contact point between the occupant and the chair is small. The same body weight over a smaller area means greater pressure on that area. Spreading the area reduces the pressure at any given point. In lieu of padding, flexible materials, such as wicker, may be used instead with similar effects of distributing the weight. Since most of the body weight is supported in the back of the seat, padding there should be firmer than the front of the seat, which only has the weight of the legs to support. Chairs that have padding that is the same density front and back will feel soft in the back area and hard to the underside of the knees. There may be cases where padding is not desirable. For example, in chairs that are intended primarily for outdoor use. Where padding is not desirable, contouring may be used instead. A contoured seat pan attempts to distribute weight without padding. By matching the shape of the occupant's buttocks, weight is distributed and maximum pressure is reduced. Actual chair dimensions are determined by measurements of the human body or anthropometric measurements. The 2 most relevant anthropometric measurement for chair design is the popliteal height and buttock popliteal length. For someone seated, the popliteal height is the distance from the underside of the foot to the underside of the thigh at the knees. It is sometimes called the stool height. The term sitting height is reserved for the height to the top of the head when seated. For American men, the median popliteal height is 16.3 inches, 410 millimeters, and for American women it is 15.0 inches, 380 millimeters. The popliteal height, after adjusting for heels, clothing and other issues, is used to determine the height of the chair seat. Mass-produced chairs are typically 17 inches, 430 millimeters, high. For someone seated, the buttock popliteal length is the horizontal distance from the backmost part of the buttocks to the back of the lower leg. This anthropometric measurement is used to determine the seat depth. Mass-produced chairs are typically 15 to 17 inches deep. Additional anthropometric measurements may be relevant to designing a chair. Research has shown that the best seated posture is a reclined posture of 100 degrees minus 110 degrees. Hip breadth is used for chair width and armrest width. Elbow rest height is used to determine the height of the armrests. The buttock knee length is used to determine legroom between rows of chairs. Seat pitch is the distance between rows of seats. In some airplanes and stadiums, the legroom, the seat pitch less the thickness of the seat at thigh level, is so small that it is sometimes insufficient for the average person. For adjustable chairs, such as an office chair, the aforementioned principles are applied in adjusting the chair to the individual occupant. Caster wheels are attached to the feet of chairs to give more mobility. Gas springs are attached to the body of the chair in order to give height adjustment and more comfort to the user. Armrests. A chair may or may not have armrests. Chairs with armrests are termed armchairs. In French, a distinction is made between fauteuil and chaise, the terms for chairs with and without armrests, respectively. In Germany, an armchair was once called a Krankensessel, or sick chair, because it was intended for people who were too ill to stand or sit without extra support. If present, armrests will support part of the body weight through the arms if the arms are resting on the armrests. Armrests further have the function of making entry and exit from the chair easier, but from the side it becomes more difficult. Armrests should support the forearm and not the sensitive elbow area. Hence, in some chair designs, the armrest is not continuous to the chair back, but is missing in the elbow area.